Assalamualaikum and hi, my name is Siti Norakila Shakira bin Rama Azizan, metric number 8190164. I am from section 8 from group M. So today I want to tell you guys the introduction and theory about projectile. So the objective of this experiment is to predict and verify the range and the time of light of a projectile launched at an angle. The introduction is projectile motion is the motion of an object that has been launched and is subject to only the force of gravity and air friction. A ball launched horizontally from a table of height has no initial velocity in the vertical direction, so the ball should take the same amount of time to reach the ground as a ball that drops from rest from the same height. The kinematic equation is h is equal to 1/2 times gt2. Can be used to determine the time of light, which is independent of initial velocity, which is the equation is t is equal to square root of 2h over g. So the theory is to predict the range of projectile when it is shot at some angle above the horizontal. We need to determine the initial speed, which is muzzle velocity of the ball. So a timer is used to measure the time the ball takes to travel between two gates. A projectile is a parabolic motion, defines superposition of two relatively simple types of motion, which is constant acceleration in one direction and constant velocity in an orthogonal direction. Rockets and guided missiles are not projectile, while the propellant is burning but become projectiles when the propelling force ceases to exist.
Hello, my name is Nazar Fahmi bin Abdul. My matrix ID is AD19015. So I want to talk about the result of the projectile experiment. So from the table there are three types of the ball, which is curve 1, curve 2 and curve ping pong. So the variable have to, which is distance in meter, time in second. For each variable there are two types, which is experimental and calculated. For the experimental, we must follow the step from the procedure and hold the experiment and get the answer. For the calculation, we must calculate with the give a formula, and it's shown in calculation part. So overall, the table was complete and there's no issue about it. Okay, that's all from me. Thank you.
The experiment is tested on different kind of material, from the lightest to the heavier option. There are two different kind of golf ball is used and a ping pong ball. The timekeeper is keen to keep up with the approximately accurate times to start the stopwatch. This is the part that may lead to many errors, and it is very challenging. The stopwatch must start when the object starts to move and stop when it hits the ground. Every second matters, and any other delay might have impact on the data collected. The experiment is then repeated using another materials, which is the golf balls too and the ping pong balls. The surrounding seems to be fine as there is no additional wind to disrupt the momentum of the object. The launching platform is smooth and no noticeable friction, and also the landing platform is set up with the carpets to avoid any damage during the landing. Every precautions are taken care.
For topic 7, projectile, we use this formula, which is we use average distance, which is L1 plus L2 plus L3 over by 3, and average time T is T1 plus T2 plus T3 over by 3, and we want to find the calculate L, which is we use L equal to ut cos theta, and v velocity u, which is we use square power of square root 2gh1 over by I plus 2 over 5 times r1 over r2 square. To find calculate t, we use h2 equal to ut sine theta minus by 1 over 2 g times 2 t2 square root. And to define the percent of different theoretical and experiment, we use theoretical value minus experiment value over by theoretical value times 100%. This is our calculation to find golf 1, golf 2, and ping pong. and for percent we use for Golf 1, also Golf 1, Golf 2, and ping pong. That's all for me. Thank you.
Hi, my name is Nirvash Bharathan, matrix number of CD190049. Today I will be discussing about the topic 7's discussion, which is projectiles discussion. For the discussion number 1, I have stated here the question of discussion number 1, and here I'm explaining on the discussion number 1. Golf ball 2 seems to have traveled a longer distance than golf ball 1 and the ping pong ball. Furthermore, golf ball 2 also took longer time compared to golf ball 1 and ping pong ball. Golf ball 1 have a slightly lower distance travel and also took shorter time than golf ball 2. However, the golf balls have traveled further than the ping pong ball and also took longer time than the ping pong ball does. For the discussion number 2, I have stated the question on the display, and here I'm explaining the same too. The golf balls and the squash balls have a different masses and size respectively. Golf balls to travel the longest and also took the longest time compared to the other two balls. Golf ball 2 is slightly heavier than golf ball 1, making the results of those two balls almost similar, but still golf ball 2 having a slight advantage of mass and size. Thus, the mass and size of the ball affect the distance traveled and the time taken for the balls to complete the experiment. And finally, we are moving to the third discussion of the lab report of topic 7, which is projectile. This would be the question of discussion 3, which was asked, and here is the answers. The results of the calculation values also further proves the theory that the mass and the size of the object affects the total distance traveled and the time taken for the balls. However, the experiment value and the calculation value is slightly different due to the presence of the friction and also inertia. Thank you. Here is my discussion for the lab report of topic 7, which is projectile. Thank you.
So for the conclusion for topic 7, the experiment have successfully portrayed the concept of the projectile motion, and the distance between the inertials and the ground motion can be determined by calculation, and it is absolutely under the gravitational action. The gravitational action and the air resistance that acts upon the release of the objects on the platform is defined as the projectile, and when the exact moment when the object is experiencing the maximum downward velocity, which is the terminal velocity. With that, thank you. During the flap